In this video, I'll review two different types of sequence: arithmetic sequences and geometric sequences. So if we start with the arithmetic sequence, if we start with 5 and then we increase by 4, we get 9, increase by another 4, we get 13, increase by another 4, we get 17, and so on. So we have a fixed step size that we add on to the previous entry in the sequence to get the next one. So if we think of this as the first entry, second entry, third entry, fourth entry, fifth entry, and so on, we think about what the 0th entry would be, and all we need to do is subtract that step size from the first entry, and 5 minus 4 comes to 1. So using the step size and the 0th entry, we can get a formula for the nth entry in the sequence. I'll call that yn, and it's equal to the step size, which is 4 in this case, times n, plus the 0th entry. So for example, y0 would be 4 times 0 plus 1 is 1. y1 would be 4 times 1 is 4, plus 1, which is 5. y2 is equal to 4 times 2, which is 8, plus 1, which is 9, and so on. So you can see that that formula is giving us the entries in the sequence. And we could keep going, and we can figure out the entry for any value of n. For example, y100 would be 4 times 100 plus 1, so 401. The geometric sequence has a fixed multiplier instead of a fixed step. So the multiplier in this case is 1.5, because if we multiply 3 by 1.5 we get 4.5, if we multiply 4.5 by 1.5 we get 6.75, if we multiply 6.75 by 1.5 we get 10.125, and if we multiply 10.125 by 1.5 we get 15.1875. And then we can use the same idea as we used for the arithmetic sequence. If we label these 1, 2, 3, 4, 5, we could figure out the 0th entry, and to do that we divide by that multiplier. So 3 divided by 1.5 is 2. And then the formula for the nth entry for a geometric sequence is equal to that multiplier, which was 1.5, to the power of n times the 0th entry. So let's just check that that gives us the right numbers. So y0 is going to be 1.5 to the 0, which is 1, times 2 is 2. y1 is going to be 1.5 to the power 1, which is 1.5, times 2 comes to 3. y2 will be 1.5 to the power 2, so 1.5 squared, which is 2.25, times 2 comes to 4.5, and so on. So sure enough, that formula is giving us the right entries in this geometric sequence. And again, we can figure out the entry for any value of n. So for example, n equals 100, it's going to be 1.5 to the power 100 times 2, and that's a really large number, which I'm going to write down using scientific notation as 8.1312 times 10 to the power 17. It's a pretty big number.